Hey there, math fans. Test 13, Lesson 4, Swords Ready, let's go. Today we're going to talk a little more about theoretical probability and writing rules for a table of values. And we will start with theoretical probability. So just a reminder to start, theoretical probability explains what happens in theory. That means what should happen given the probabilities. Experimental probability is what results you get when you do an experiment to test the probability. They'll usually be similar, but they're often not exactly the same. For example, if I toss a coin 4 times, I should get heads twice and tails twice. That would be the theoretical probability. If I actually do that, I might get heads 3 times and tails once. That would be my experimental probability. It's kind of close, but it's not exact. The more times you do the experiment, the closer you'll get to theoretical probability. I could toss a coin 4 times and get all heads, but if I tossed it 400 times and got all heads, that would be pretty unlikely. So remember that when we're talking about theoretical probability, we're talking about the number of favorable outcomes out of all possible outcomes. So here's an example. Ken has a stack of cards numbered 1 to 5, and the ace is the 1, obviously. If he draws 2 at random, what is the theoretical probability that their sum will be an even number? So the first thing I need to do, remember theoretical probability is the favorable outcomes, which in this case is the even number sums, out of the total possible outcomes. So I need to find out how many possible answers there are. Now this question is asking me about sums, which means addition. So I'm going to draw out all the possible outcomes I could get. So if card 1 is a 1, card 2 could be a 2, 3, 4, or 5. It couldn't be a 1 because I only have 5 cards. So then my sums would be 3, 4, 5, and 6. 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6. Those are the possible sums. There's no other possibilities with a 1, so I'm going to move on to my second option, which would be the first card I draw being a 2. And that looks like this. So here again, those are all my first options. Now if my second card is a 2, if my first card is a 2, my second card could be a 1, 3, 4, or 5, giving me the sums 3, 5, 6, and 7. No more possibilities with 2, so I'm going to move on to 3. If card 1 is a 3, card 2 could be 1, 2, 4, or 5, giving me the sums 4, 5, 7, 8. That's it for 3, so I'm going to move on to 4. Please notice, though, that what I'm doing here is I'm staying organized. I did all my 1s, all my 2s, all my 3s, now I'm doing all my 4s. I'm not jumping all over the place because if I do that, then I'm going to get confused. So if card 1 is a 4, card 2 can either be 1, 2, 3, or 5, giving me the sums 5, 6, 7, or 9. And finally, if the first card is a 5, the second card could be 1, 2, 3, or 4, giving me the sums 6, 7, 8, or 9. So going back to my original question, what I wanted to find out is the probability of getting an even sum. So what I have to do, I found out all possible sums, and now I need to find out the number of even sums. So all possible sums, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So my final answer will be out of 20. There are 20 possible sums. Now how many of them are even? We just have to go through the list. So 3 is not, 4 is, 5 is not, 6 is, 3 is not, 5 is not, 6 is, 7 is not, 4 is, 5 is not, 7 is not, 8 is, 5 is not, 6 is, 7, 9 are not, 6 is, 7 is not, 8 is. So there's my even number. And there are 1, 2, 3, 4, 5, 6, 7, 8 of those. So the probability of getting an even sum when you draw 2 cards numbered 1 through 5 is 8 out of 20. And I can actually reduce that if I want to. I can reduce both of those by 4. So 8 divided by 4 is 2, 20 divided by 4 is 5, so 2/5. But 8 out of 20 works as well. So our second objective is writing rules for a table of values, and I don't really have a lot to say to you about that because we've gone through it. So I'm just going to give you a quick reminder on it, then the review, and then I have a short Spy Guys thing for you to go through. So the reminder is that when you write an equation for a table of values, it describes the relationship or pattern between the two columns. So you'll have a column. It's sometimes called the table of values, sometimes called a function table. It doesn't matter. But your equation that you write is going to describe what is happening between those two columns. So here's your review. If you roll two four-sided dice, what is the theoretical probability of getting the same number on both dice? And remember, on that one, you're going to have to figure out all the possibilities and then mark down the ones that give you that probability. And number two, what rule would allow the following table of values? So here's your R, here's your Q. They're all listed for you. You just need to write down the rule that would allow the table of values. So please pause the video here and quickly do this review. And when you come back, I have one last little thing for you to do. And the last thing I'll ask you to do today is go to www.tinyurl.com/spyguysvolume. And this is a really important one for you to check out because it's going to be the basis for a lot of what we do for the next few weeks. So please make sure you do it. And that's it. I will see you tomorrow. Have a great night.